Welcome to Blue Marble Geographics Ask the Experts. I'm Rachel Landry, and this is Mackenzie Mills, an application specialist. Mackenzie will be taking us through a workflow to apply elevations to an area feature based on loaded terrain data. Mackenzie, take it away.
All right, so to start, we'll take a look at the layers that we have in our workspace here. First, we've got our loaded terrain data, this underlying digital elevation model shaded with an elevation shader here. And then we have an area feature sitting on top of that. And this is just an area feature created with the digitizer tool in Global Mapper, although it could absolutely be one that you've loaded from an external file. To take a closer look at this area feature to start with, we're going to grab our feature info tool, click on our area feature, and we can see we have a few measure attributes for this feature, but no elevation or z-value attribute. Looking a little closer, we can go ahead and click to view our feature vertices. So our feature vertex list here. Again, we see we have an X and Y location for each feature vertex, but we don't have any elevation values here. Now, in this dialog, we can go ahead and add an elevation value just by typing in manually an elevation for each vertex, or we can update elevations from our loaded terrain data. And while you can do this through that dialog, and this is what we'll be doing today, a more straightforward workflow for many users of Global Mapper might be to do this through the digitizer tool. So I'll switch tools here. I'll go ahead and grab the digitizer from our toolbar. Again, select our area feature. And then from our digitizer menu, go to Analysis Measurement, Apply Elevations to Selected Features. Here we can choose to apply our elevations from our loaded terrain data. You can see that we have some other options here that are grayed out. They may be available depending on what data you have in your workspace. Clicking OK, we apply those elevations, and nothing really changes in this 2D view, but still with our digitizer tool, we can go back to view those feature vertices. Right-clicking, we can go to Edit Feature Vertices and view our feature vertex list again. You can see here now we still have that X and Y location for each vertex, but we also have that Z value. And that Z value has been pulled from the terrain data at each vertex location. Clicking on a vertex, we see that it highlights in that 2D main view, and we can see our high point vertex and our low point vertex, the low point being at about 42.7 meters here. Now, these vertices have differing elevations across the elevation feature, or across the area feature, because they have been pulled from the underlying terrain where the elevation is variable across this area. We can go ahead in this dialog and choose to edit individual vertex elevations by clicking the Edit Elevation option here and just manually typing in the altered elevation value we'd like to apply. If we would like to offset the entire elevation or the entire area feature by a specific elevation value, we can do that as well through the use of the digitizer tool. So going back to our 2D view, we can use our digitizer right-click options with that area feature still selected and go to Move Reshape Features and choose to shift or offset our area feature. In this dialog, we have the option to choose from various unit types. We'll choose meters for this example, and we can choose to offset this feature in the X and Y directions if needed, but right now we're just focusing on that Z or elevation offset. So we'll go ahead and enter an offset value of 10 here to bump up all of our per vertex elevations by 10 meters. With that entered, we can click OK, and once again we'll see that nothing really changes in this 2D view. But going back to our feature vertex list with our right-click option here, we can see that those Z values, those per vertex elevations have changed. They've all been increased by 10. So now our low point vertex elevation here is at about 52.7 meters. Since this is now a 3D area feature, it makes sense to look at it in the 3D viewer. We can pull that up and zoom in closer to our area feature here. And looking at it, we can see that it does slope to match the terrain layer that we have loaded. but the actual area feature shows about 10 meters above that terrain surface because we have offset that elevation, adding 10 to each of those per vertex elevations.
Mackenzie, thank you so much for walking us through that workflow. I actually didn't know that Global Mapper could do that. Is there a particular industry that this would work best for, or that anyone could use it for something specific, or just is this more of a general workflow?
Fairly general workflow that can be applied to a lot of situations. We demonstrated with an area feature here, but this can be done with line features as well if you'd like to make a line sort of match your terrain or be offset based on the terrain that you have loaded in your workspace.
Thank you so much, Mac, for taking time out of your day to do this with us. And thank you all for joining us to watch Ask the Experts. Be sure to stay tuned for our next episode.